Namaste dear children, I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see NCERT Class 6 Maths Chapter 5 Prime Time Part 5. Divisibility Test. So far we have been finding factors of numbers in different contexts, including to determine if a number is prime or not, or if a given pair of numbers is co-prime or not. So to check whether a number is prime or not, or to check if a given pair of numbers is co-prime or not, we use factorization. It is easy to find factors of small numbers. How do we find factors of a large number? Let us take 8560. Does it have any factors from 2 to 10, 2, 3, 4, 5, etc., 9, 10? It is easy to check if some of these numbers are factors or not without doing long division. Can you find them? It is easy to find factors of small numbers, but it is not easy to find factors of large numbers. For some numbers, it is very easy to check if that number is a factor without doing long division. We will see. Divisibility by 10. Let us take 10. Is 8560 divisible by 10? This is another way of asking if 10 is a factor of 8560. Both are same. Is 8560 divisible by 10? This is same as asking if 10 is a factor of 8560. For this, we can look at the pattern in the multiples of 10. The first few multiples of 10 are 10, 20, 30, 40, etc. Continue this sequence and observe the pattern. So first we can find the multiples of 10. The first few multiples of 10 are 10, 20, 30, 40, 50, 60, etc. You observe this pattern. What is the peculiarity of this pattern? Is 125 a multiple of 10? Will this number appear in the previous sequence? Why or why not? No, 125 is not a multiple of 10. A multiple of 10 is any number that can be divided by 10 without leaving a remainder. So, what is a multiple of 10? A multiple of 10 is any number that can be divided by 10 without leaving a remainder. When we divide 125 by 10, we get 12 with a remainder of 5. Therefore, 125 is not a multiple of 10. If you divide 125 by 10, you will get quotient as 12. Then what is the remainder? 5. So, 125 is not a multiple of 10. If it is a multiple of 10, then it will not leave any remainder. Can you now answer if 8560 is divisible by 10? Yes, 8560 is divisible by 10. Why? A simple rule to check for divisibility by 10 is to look at the last digit. The last digit of a number is 0. Then the number is divisible by 10. So, you look at the last digit of the number. If the last digit of the number is 0, then that number is divisible by 10. Since 8560 ends with 0, it is divisible by 10. Consider this statement. Numbers that are divisible by 10 are those that end with 0. Do you agree? Yes. This is very important. This is the rule of divisibility by 10. Numbers that are divisible by 10 are those that end with 0. Divisibility by 5. The number 5 is another number whose divisibility can easily be checked. How do we do it? So it is easy to check whether a number is divisible by 5 or not. Explore by listing down the multiples 5, 10, 15, 20, 25. What do you observe about these numbers? Do you see a pattern in the last digit? We can observe a clear pattern in the last digit of these multiples. The last digit alternates between 5 and 0. Look at this pattern. See, 5. The last digit is 5. Then 10, last digit is 0. 15, last digit is 5. 20, last digit is 0. 25, last digit is 5. So, The last digit alternates between 5 and 0. This pattern holds true for all multiples of 5. This is a useful trick to quickly identify multiples of 5. You just look at the last digit. If it is either 0 or 5, then it is divisible by 5. What is the largest number less than 399 that is divisible by 5? The largest number less than 399 that is divisible by 5 is 395. Is 8560 divisible by 5? Yes, 8560 is divisible by 5. A number is divisible by 5 if its last digit is either 0 or 5. Since 8560 ends with a 0, it is divisible by 5. Consider this statement. Numbers that are divisible by 5 are those that end with either a 0 or a 5. Do you agree? Yes. This is very important. This is a rule of divisibility by 5. Numbers that are divisible by 5 are those that end with either a 0 or a 5. You just look at the last digit of the number. If it is either 0 or 5, then it is divisible by 5. Next is divisibility by 2. The first few multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, etc. What do you observe? Do you see a pattern in the last digit? Yes. What is a pattern? 0, 2, 4, 6, 8. This is a pattern. That is, the last digit is an even number. Is 682 divisible by 2? Can we answer this without doing the long division? Yes, we can determine if 682 is divisible by 2 without long division. A simple rule for divisibility by 2 is if the last digit of a number is even, that is 0, 2, 4, 6 or 8, then the number is divisible by 2. So, if the last digit of a number is an even number, then the number is divisible by 2. Is 8560 divisible by 2? Why or why not? Yes, 8560 is divisible by 2. Why? A number is divisible by 2 if its last digit is even, that is 0, 2, 4, 6 or 8. Since the last digit of 8560 is 0, it is divisible by 2. Consider this statement. Numbers that are divisible by 2 are those that end with the 0, 2, 4, 6 or 8. Do you agree? Yes. This is a rule of divisibility by 2. Numbers that are divisible by 2 are those that end with 0, 2, 4, 6 or 8. That is, a number should end with an even number. What are all the multiples of 2 between 399 and 411? The multiples of 2 between 399 and 411 are 400, 402, 404, 406, 408, 410. Divisibility by 4. Checking if a number is divisible by 4 can also be done easily. Look at its multiples 4, 8, 12, 16, 20, 24, 28, 32. Are you able to observe any patterns that can be used? The multiples of 10, 5 and 2 have a pattern in their last digits, which we are able to use to check for divisibility. Similarly, can we check if a number is divisible by 4 looking at the last digit? It does not work. So, in order to check whether a number is divisible by 2, 5 or 10, we can use the last digit of the number. But in the case of divisibility by 4, looking at the last digit, we cannot check whether that number is divisible by 4. Look at 12 and 22. They have the same last digit. But 12 is a multiple of 4 while 22 is not. So when you consider the two numbers 12 and 22, the last digit is 2. But 12 is a multiple of 4, but 22 is not a multiple of 4. Similarly, 14 and 24, they have the same last digit. They have the same last digit 4, but 14 is not a multiple of 4, while 24 is a multiple of 4. Similarly, 16 and 26 or 18 and 28. What this means is that by looking at the last digit, we cannot tell whether a number is a multiple of 4. So, looking at the last digit, we cannot tell whether a number is a multiple of 4. Can we answer the question by looking at more digits? Make a list of multiples of 4 between 1 and 200 and search for a pattern. Find the numbers between 330 and 340 that are divisible by 4. Also find numbers between 1730 and 1740 and 2030 and 2040 that are divisible by 4. What do you observe? Is 8536 divisible by 4? All these questions we will solve. Consider these statements. Only the last two digits matter when deciding if a given number is divisible by 4. So, in order to check whether a number is divisible by 4, only the last two digits of the number will matter. If the number formed by the last two digits is divisible by 4, then the original number is divisible by 4. So, if the number formed by the last two digits is divisible by 4, then the original number is also divisible by 4. If the original number is divisible by 4, then the number formed by the last two digits is divisible by 4. Do you agree? Yes. Find numbers between 330 and 340 that are divisible by 4. Also find numbers between 1730 and 1740 and 2030 and 2040 that are divisible by 4. What do you observe? So numbers divisible by 4 between 330 and 340 are 332 and 336. The numbers divisible by 4 between 1730 and 1740 are 1732 and 1736. The numbers divisible by 4 between 2030 and 2040 are 2032 and 2036. Then, what is the observation? We observe that for a number to be divisible by 4, the last two digits of the number must be divisible by 4. So, for a number to be divisible by 4, what is the condition? The last two digits of the number must be divisible by 4. For instance, in the number 332, the last two digits 32 are divisible by 4. 32 is divisible by 4. Similarly, for 1732, the last two digits 32 are divisible by 4. This rule provides a quick way to check divisibility by 4 without performing long division. Is 8536 divisible by 4? Yes, 8536 is divisible by 4. Why? In the case of 8536, the last two digits are 36, which is divisible by 4. Therefore, 8536 is divisible by 4. Divisibility by 8. Interestingly, even checking for divisibility by 8 can be simplified. Can the last two digits be used for this? Find numbers between 120 and 140 that are divisible by 8. Also find numbers between 1120 and 1140 and 3120 and 3140 that are divisible by 8. What do you observe? So numbers divisible by 8 between 120 and 140 are 128 and 136. The numbers divisible by 8 between 1120 and 1140 are 1120, 1128 and 1136. numbers divisible by 8 between 3120 and 3140 are 3120, 3128 and 3136. What is observation? Similar to divisibility by 4, we observe a pattern for divisibility by 8. For a number to be divisible by 8, the last 3 digits of the number must be divisible by 8. So, for a number to be divisible by 8, the last 3 digits of the number must be divisible by 8. Change the last 2 digits of 8560 so that the resulting number is a multiple of 8. So we have to change the last 2 digits in such a way that the resulting number must be a multiple of 8. So to make 8560 divisible by 8, we need to change the last 2 digits to 84. We can replace 60 with 84 to get the number 8584. So 8584 is a multiple of 8 because 584 divided by 8 is equal to 73. So 8584 is divisible by 8. Consider these statements. Only the last 3 digits matter when deciding if a given number is divisible by 8. So to check whether a number is divisible by 8, we have to consider the last 3 digits of that number. If the number formed by the last 3 digits is divisible by 8, then the original number is divisible by 8. So, when you consider the last 3 digits, if the number formed by the last 3 digits is divisible by 8, then the original number is divisible by 8. If the original number is divisible by 8, then the number formed by the last 3 digits is divisible by 8. Do you agree? Yes. We have seen that long division is not always needed to check if a number is a factor or not. We have made use of certain observations to come up with simple methods for 10, 5, 2, 4, 8. Do we have such simple methods for other numbers as well? We will discuss simple methods to test divisibility by 3, 6, 7 and 9 in later classes. Figure it out. 2024 is a leap year as February has 29 days. Leap years occur in the years that are multiples of 4 except for those years that are evenly divisible by 100 but not 400. So, leap years occur every 4 years except for certain exceptions related to century years. From the year you were born till now, which years were leap years? So leap years between 2013 and 2024 are 2016, 2020 and 2024. From the year 2024 till 2099, how many leap years are there? There are 19 leap years between 2024 and 2099. See 2024, 2028, then 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, then 2072, 76, 80, 84, 88, 92 and 2096. Find the largest and smallest 4-digit numbers that are divisible by 4 and are also palindromes. Should be divisible by 4 and should be also a palindrome. So the smallest 4-digit palindrome divisible by 4 is 2112. What is a palindrome? Palindrome is a word, phrase or sequence that reads the same backwards as forwards. So the smallest 4-digit palindrome divisible by 4 is 2112. The largest 4-digit palindrome divisible by 4 is 8888. Explore and find out if each statement is always true, sometimes true, or never true. You can give examples to support your reasoning. First one, sum of two even numbers give a multiple of 4. The statement, the sum of two even numbers gives a multiple of 4 is sometimes true. It is sometimes true. While the sum of two even numbers is always an even number, it is not necessarily a multiple of 4. See this example. 2 plus 6 is equal to 8. Here, 2 and 6 are even numbers. Their sum is also an even number. And 8 is also a multiple of 4. This is a true case. But you can consider a false case like this. 4 plus 6 is equal to 10. 4 and 6 are two even numbers. Their sum is equal to 10. It is an even number, but 10 is not a multiple of 4. Next one, sum of two odd numbers gives a multiple of 4. The statement sum of two odd numbers gives a multiple of 4 is sometimes true. While the sum of two odd numbers will always be an even number, it is not necessarily a multiple of 4. See an example for a true case. 3 plus 5 is equal to 8. See here 3 and 5 are odd numbers. Their sum is an even number. 3 plus 5 is equal to 8. Here 8 is a multiple of 4. This is a true case. See another example, an example of a false case. 1 plus 5 is equal to 6. Here 1 and 5 are odd numbers. Their sum is 6. 6 is an even number, but 6 is not a multiple of 4. Find the remainders obtained when each of the following numbers are divided by 10, 5, 2. The numbers are 78, 99, 173, 572, 980, 1111, 2345. See this table. The numbers are given here and the remainder when divided by 10. So first number 78. 78 when divided by 10 we will get remainder as 8. Then 78 when divided by 5 we will get remainder as 3. Then 78 when divided by 2 we will get remainder is equal to 0. Similarly you can do the entire thing. The teacher asked if 14,560 is divisible by all of 2, 4, 5, 8 and 10. Guna checked for divisibility of 14,560 by only two of these numbers and then declared that it was also divisible by all of them. What could those two numbers be? So here Guna checked for divisibility of 14,560 by only two of the numbers 2, 4, 5, 8 and 10 and then declared that it was also divisible by all of them. We have to find those two numbers. See, if a number is divisible by 8, then it is automatically divisible by 4. If a number is divisible by 10, then it is automatically divisible by 2 and 5. Okay, so since 14,560 is divisible by 8 and 10, it is automatically divisible by 2, 4, 5, 8 and 10. Which of the following numbers are divisible by all of 2, 4, 5, 8 and 10? Here the numbers given are 572, 2352, 5600, 6000, 7 crore, 76 lakh, 22,160. If a number is divisible by all of 2, 4, 5, 8 and 10, then it must be divisible by 8 and 10. See the divisibility rules. Divisibility by 10. Last digit must be 0. Then if a number is divisible by 8, the last three digits are divisible by 8. Then checking the numbers. 572. Take the first number 572. This number is not divisible by 10. Why? The last digit is not 0. Then take the second number 2352. This is also not divisible by 10. Why? The last digit is not 0. The next one 5600. This is divisible by 2, 4, 5, 8 and 10. The next one, 6,000. This is divisible by 2, 4, 5, 8 and 10. The next one, 7 crore 76 lakh 22,160. This is also divisible by 2, 4, 5, 8 and 10. Therefore, the numbers 5,600, 6,000 and 7 crore 76 lakh 22,160 are divisible by all of 2, 4, 5, 8 and 10. Write two numbers whose product is 10,000. The two numbers should not have 0 as a units digit. So 10,000, we can write it as 10 into 10 into 10 into 10. So we can factorize this. 10 is equal to 2 into 5. Again, second 10 is 2 into 5. Third 10, 2 into 5. Then fourth 10, 2 into 5. So, for convenience, we can write in this order 2 into 2 into 2 into 2 into 5 into 5 into 5 into 5. So, this is equal to 16 into 625. Hence, 16 and 625 are the two numbers whose product is 10,000. These numbers do not have 0 in their units place. Fun with numbers. Special numbers. There are 4 numbers in this box. Which number looks special to you? Why do you say so? See this box. There are 4 numbers 9, 16, 25 and 43. Look at what Guna's classmates have to share. Karnavati says 9 is special because it is a single digit number, whereas all the other numbers are 2-digit numbers. Gurupret says 9 is a special number because it is the only number that is a multiple of 3. Then Murugan says 16 is special because it is the only even number and also the only multiple of 4. Kobiga says 25 is special as it is the only multiple of 5. Then Yetigi says 43 is special because it is the only prime number. Radha says 43 is special because it is the only number that is not a square. Because 9, 16 and 25 are squares. 3 square is 9, 4 square is 16, 5 square is 25. Below are some boxes with 4 numbers in each box. Within each box, try to say how each number is special compared to the rest. Share with your classmates and find out who else gave the same reasons as you did. Did anyone give different reasons that may not have occurred to you? See the first table. The table contains 5, 7, 12, 35. 5 and 7 are prime numbers. 5 and 7 are prime numbers. Then 12 is the smallest composite number in this box. Then what about 35? 35 is the product of two prime numbers, 5 and 7. See the second box. The box contains numbers 3, 8, 11, 24. 3 and 11, they are prime numbers. Then 8 is power of 2. 2 into 2 into 2. Then 24 is divisible by many numbers. Then see box number 3. The numbers are 27, 3, 123 and 31. Here 27 is a power of 3. Then 3 is a prime number. Then 123 is divisible by 3. Then 31 is a prime number. Then see box number 4. Here the numbers are 17, 27, 44 and 65. 17 is a prime number. 27 is a power of 3, that is 3 cube, 3 into 3 into 3. Then 44 is divisible by 4. 65 is a product of two prime numbers, 5 and 30. A prime puzzle. The figure on the left shows the puzzle. The figure on the right shows the solution of the puzzle. Think what the rules can be to solve the puzzle. See here, 5 into 5 into 3 is 75. 2 into 3 into 7 is 42. 17 into 2 into 3 is 102. Similarly, 5 into 2 into 17 is 170. 5 into 3 into 2 is 30. 3 into 7 into 3 is 63. So, here the grid is filled with the prime numbers only. So that the product of each row is the number to the right of the row and the product of each column is the number below the column. Rules. Fill the grid with prime numbers only so that the product of each row is a number to the right of the row and the product of each column is a number below the column. See, 7 into 5, 35 into 3 is 105. Then 2 into 5 into 2 is 20. 2 into 5 into 3 is 30. See, similarly, the product of each column is the number below the column. 7 into 2 into 2 is 28. 5 into 5 into 5 is 125. 3 into 2 into 3 is 18. The next one, 2 into 2 into 2 is 8. Then 3 into 5 into 7 is 105. 5 into 7 into 2 is 70. Similarly, 2 into 3 into 5 is 30. 2 into 5 into 7 is 70. 2 into 7 into 2 is 28. Similarly, 3 into 7 into 3 is 63. 3 into 3 into 3 is 27. 5 into 2 into 19 is 190. 3 into 3 into 5 is 45. 7 into 3 into 2 is 42. Then 3 into 3 into 19 is 171. Children, thanks for watching. If you like this video, please like, share and subscribe. We will see in the next video. The playlist for all subjects is given in the description box. Please go through it. Thank you.